to an Introduction to Evidence-Based Undergraduate STEM Teaching, an open online course for current and future STEM faculty. I'm Trina McMahon. I'm a professor of civil and environmental engineering at the University of Wisconsin-Madison. I'm also a co-faculty director in the Delta program at UW-Madison, which is an organization that's dedicated to the development of future faculty. I teach several courses each semester. I teach an introductory course in engineering, a sophomore junior level course in environmental engineering, which is my specialty. I also teach part of an honors biology course and a course in environmental microbiology.
And I'm Derek Bruff. I'm the director of the Center for Teaching at Vanderbilt University and a senior lecturer in mathematics. I teach in the math department. I teach a course in statistics and linear algebra from time to time, and a really fun course in cryptography. As part of the Center for Teaching, we work with faculty and graduate students all over the campus to help them develop foundational teaching skills and to try out new ideas in teaching and learning. Let's unpack this course title a little bit. An Introduction to Evidence-Based Undergraduate STEM Teaching. STEM stands for Science, Technology, Engineering, and Mathematics. That refers to a group of disciplines that have a similar way of making sense of the world and definitely have a lot of commonalities in how they teach and how they approach teaching. And so those are the disciplines that we'll be focusing on in this course.
So let's talk about undergraduate STEM teaching. This course is mainly focused on undergraduate teaching, and you might think this could also apply, some of the principles that we talk about could also apply to high school or graduate school, but we're mainly focused on undergraduates, and specifically undergraduates in the United States.
So what do we mean by evidence-based? Well, let's take a recent example, a journal article that got a fair amount of attention. It's an article that was published in the Proceedings of the National Academies of Science by Scott Freeman and colleagues. And in this article, they analyzed 228 control group studies. Each of these studies compared more or less a kind of traditional lecture-based classroom environment with a classroom in which active learning was present. And so on the one hand, you had courses that were primarily lecture-based. Students were in class kind of passively taking notes. And in the other cases, you had classrooms in which students were interacting with each other, with the material, often through small group activities. And so they had 228 studies like that they analyzed. And they had a couple of key findings that I think are really important. One is that the students in the lecture-based courses actually failed at a rate 1.5 times that of the failure rate in the active learning classrooms. So the students in the active learning classrooms, about 22% of those students failed across all the studies. In the lecture classrooms, it was 34%. Another key finding, that the final course grades in the active learning classrooms were actually 6 points higher on a 100-point scale than the final grades in the lecture-based classrooms. This is pretty persuasive evidence that STEM educators should adopt active learning strategies when they teach. Trina, when did you start using active learning approaches in your teaching?
Well, Derek, when I was a PhD student, I didn't have access to a course like this. And so when I first entered the classroom, it was a pretty rough experience as an assistant professor. I set up my course just as 50-minute lectures where I just blathered on to the students and they got really bored and didn't learn very much. So it wasn't until I took a short version of this course, basically, or a course that's really similar to this one, and learned a few key tricks. And the first thing that I applied that really changed the dynamic of my classroom was to break my lectures up into 15-minute blocks and intersperse those with active activities where students will answer a problem or work in groups to talk about a particular concept. And this really simple redesign of my class time was so powerful in terms of bringing the energy level up and keeping the students engaged that I was totally convinced that active learning was the way to go. One thing I learned through that process also was that we have a lot of choices to make as teachers. We get to decide what to assign both inside and outside of the classroom in terms of the activities. We have to decide how to structure in-class interactions and how to craft the content of our lectures in our labs. But there's really no reason why this should be something that we just copy what we experienced as undergraduates in our own learning, because it actually doesn't work very well for most learners. We should actually use evidence-based research, so research on teaching and learning that can to inform our teaching choices. And this course is going to help you learn how to do that.
So in this course, we'll see what the research says about how learning works, about the role of learning objectives and assessment of learning. And we'll spend some time talking about active learning and what that looks like in the classroom. We'll delve into the importance of inclusive teaching practices as well. And in the final activity in this course, you'll get to design a lesson plan where you draw all these ideas and concepts together and apply them to a course or a lesson that you might teach one day in your own discipline.
You may be wondering right now who's putting this course together. This course has been designed by a team of staff and faculty from the CERTL network. CERTL stands for the Center for the Integration of Research, Teaching, and Learning, and it's actually a distributed center because it's at many different institutions across the United States, in fact more than 20 of them. And they range from public to private, small to large. And the faculty and staff at those institutions who are helping us with this course have as their mission to prepare future faculty to teach in STEM. And so we're drawing on that expertise within the network, as well as expertise outside of the network, to put this course together for you. Now, the CERTL network has 3 core ideas that are going to permeate throughout this course. And so I want to go through them really quickly. The first is teaching as research, and this basic idea is that you can approach your classroom teaching as a research project, and you can continuously improve and iterate in order to maximize student learning. And this was a really transformative concept for me when I was first learning how to teach as an assistant professor. The second core idea is the concept of a learning community, and learning communities actually operate at 2 different scales. The first would be students within your class supporting each other in the process of teaching, or in the process of learning and discovery, as well as the community that you belong to as an instructor with other instructors, and even in this course as someone learning how to teach. The third core idea is learning through diversity, and this concept means that we can draw upon the experiences and the backgrounds and the skills that students bring to our classrooms to actually enhance learning.
Speaking of learning communities, we have set up a variety of ways for you in this course to interact with the content and particularly with each other. Certainly we have a lot of videos for you to watch that will introduce some key ideas and some of the research on teaching and learning. A lot of these videos have embedded questions that you can respond to that will help you reflect on what you're learning. But just as importantly, we have discussion forums where we encourage you to share your personal experiences, your own perspectives on teaching and learning. And one of the opportunities I think we have in a course with this many participants is to explore how some of these teaching and learning ideas play out differently in different disciplines or in different institutional contexts. So we encourage you to kind of explore some of those differences in the discussion boards as well. We'll have weekly quizzes that will help you reflect on the material, some peer-graded assessments along the way so you can give some structured feedback to each other on your work, including that lesson plan activity that I mentioned. We also think that local learning communities are a key part of this experience. And so we encourage you to seek out colleagues in your area, on your campus, maybe other grad students, other faculty, other postdocs, that you can meet with and interact with as you're taking this course, and talk to each other and help each other apply what you're learning in this course to the teaching that you do. If you're interested in facilitating a local learning community, please let us know. We have some additional resources we can provide you that will make that a little bit easier.
We're really looking forward to getting to know you and participating in that learning community. So jump right in.